Hey everyone, and welcome back for another deep dive.
It's great to be back.
So today we're going to be looking at something pretty cool.
Yeah, definitely.
It's, for all of our listeners out there getting ready for the UPSC exams,
All right.
we thought this would be a really good one to cover
Absolutely.
because it's about a recent discovery and it has to do with physics,
Yeah.
which is, something that comes up.
It comes up a lot in the mains and also even the prelims.
Yeah, exactly.
For sure.
And we're going to be basing this deep dive on a really interesting article we found
Okay.
in the Hindu newspaper.
Nice.
And basically, it's all about this new particle, or this newly discovered particle, I should say,
Sure.
called the Semi-Dirac Fermion.
Interesting.
And this particle has a very unique property.
Okay. I'm interested to hear more.
Yeah, so just imagine this.
Okay.
Like, picture a particle that has mass when it moves in one direction,
Okay.
but then when it moves in a different direction, it becomes massless.
Whoa, wait, hold on.
No.
So it loses its mass depending on which way it's going.
It's pretty mind-blowing.
That is wild.
So yeah, we're going to unpack that whole thing.
Awesome.
So first of all, what exactly is a Semi-Dirac Fermion?
Okay, so a semi-Dirac fermion is this fascinating particle. And like you mentioned, what makes it so unique is this property called directional mass.
Right.
It basically means that it has mass when it's moving in one direction, but when it moves in a perpendicular direction, it becomes massless.
Okay, so that's kind of what I was picturing.
Exactly.
Like if it's moving horizontally, it has mass, but if it's moving vertically, it doesn't.
Yeah, you got it. And this is where it gets really relevant for the UPSC syllabus because this discovery falls under the topics of general science and current affairs related to scientific advancements.
Oh, okay. So they could totally ask about this on the exam.
Definitely, they could ask a conceptual question about the properties of semi-Dirac fermions, or even a specific question about where they were discovered.
Interesting. And I think you mentioned this a little bit ago, but where were these semi-Dirac fermions discovered?
So they were actually observed in a material called zirconium silicon sulphide.
Zirconium silicon sulphide.
Yeah, it's a mouthful. I know, but this is actually really important for the prelims because knowing these specific materials, where these unique particle behaviors are observed, that could really give you an edge in the exam.
Gotcha. So it's not enough just to know about the particle itself, but also where it was found.
Exactly. The UPSC loves to test your in-depth knowledge.
Okay, so this semi-Dirac fermion, it's found within this specific material.
Right.
Does that mean that it's not like a fundamental particle?
That's a great question.
Like an electron or something?
You've hit on a really important point here. So the semi-Dirac fermion is actually categorized as a quasiparticle.
A quasiparticle.
Yeah, it's not a fundamental building block of matter like an electron or a quark.
Okay.
It's more like it emerges from the collective behavior of electrons within that zirconium silicon sulphide.
Okay, so it's kind of like a team effort.
Exactly.
Like you've got all these electrons working together, and they're creating this unique particle with its directional mass.
That's a great way to put it. It's a fascinating example of how emergent properties arise from complex interactions.
That's really cool.
So to understand what makes semi-Dirac fermions so unique, let's zoom out a bit and talk about particles more broadly.
Yeah.
You know, the UPSC syllabus really emphasizes the standard model of particle physics.
Right, the standard model.
Exactly. And this model categorizes all the fundamental particles in the universe.
Yeah, and that's where we get those terms like fermions and bosons.
You got it.
And I remember learning about this thing called the Pauli Exclusion Principle.
Oh, yeah, that's a big one.
It applies to fermions.
Absolutely. The standard model is crucial for understanding the universe. And within this model, we have those two main groups you mentioned, fermions and bosons.
Right.
Now, fermions, like electrons and quarks, are the building blocks of matter.
Okay.
And the Pauli Exclusion Principle states that two identical fermions can't occupy the same quantum state. And this is actually why matter has solidity and why we don't just fall through our chairs.
Oh, wow. So it's thanks to fermions that I'm not like a ghost.
Precisely.
That's amazing.
So now to compare our semi-Dirac fermion, let's look at a typical fermion, like the Dirac fermion, named after Paul Dirac. These fermions have mass and are distinct from their antiparticles.
Okay, so we've got fermions like electrons. They make up matter. They have these antiparticle counterparts. What about bosons, though?
Right, so bosons are a different breed altogether. They are force carriers.
Okay.
So for example, photons, the particles of light, are bosons that mediate the electromagnetic force.
Okay.
And then you have gluons, which hold the nucleus of an atom together.
So fermions are like the building blocks, and bosons are like the messengers that carry forces between them.
That's a really good analogy.
Cool. So where do these new semi-Dirac fermions fit into all of this?
Their discovery really challenges our understanding of fermion behavior because unlike Dirac fermions that have mass in all directions, semi-Dirac fermions have this unique directional dependence. It raises a lot of questions about how these quasiparticles might interact with other particles and forces.
It sounds like this discovery could have some big implications
Oh, absolutely.
for how we understand the universe.
Yeah, at a very fundamental level.
Could this lead to any new technologies or applications?
That's the exciting part. It's still early days, but the unique properties of semi-Dirac fermions could really lead to advancements in fields like quantum computing and materials science.
Oh, wow.
Imagine being able to harness directional mass to control the flow of information or energy.
That would be incredible.
It really could revolutionize technology as we know it.
So for our UPSC aspirants out there, this discovery is a prime example of how staying updated on current scientific breakthroughs is essential.
I completely agree.
This knowledge could be so valuable for essay writing in the mains exam.
Absolutely. It shows you're aware of cutting-edge developments.
Exactly.
And it demonstrates a deeper understanding of scientific principles and their potential impact, which is a key aspect of the UPSC exam.
Well said. So today we've delved into the fascinating world of the Semi-Dirac Fermion, a quasiparticle with that unique directional mass. We've explored its implications for particle physics and its potential to revolutionize technology.
It's amazing to think that we're still uncovering these fundamental mysteries of the universe.
It really is. And who knows what other groundbreaking discoveries await us as we continue to explore.
It's an exciting time for sure.
It definitely is. And on that note, we encourage you to delve deeper into this topic and explore the original article in the Hindu. If you enjoyed this deep dive, don't forget to subscribe to our podcast for more insightful explorations of the world around us. Until next time, keep those minds curious and engaged.
And keep exploring.
See you next time.